And here we go again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, nobody emailed me any questions, but perhaps you have some before we go on to section 6.6. So are there any questions that you'd like to look at from 6.4, I believe it was?
I just have a general question. At the beginning of the homework, a lot of times they'll be like fill in the blank. Like they'll have like the trinomial, then you put in perfect square trinomial. Are those questions going to be on the exam, or is it just going to be solving and factoring?
That's a good question. I would say if there are any, there won't be a lot of them, but you should be able to deal with the vocabulary. That's an important part of the thing, not just the numbers, but so I would say expect them. Okay. There, I'm not really committing to whether they'll be on there or not, as you were hoping I would, but you should be familiar with the vocabulary.
Okay, thank you.
You're welcome. All right. Any other questions, something you want me to do from last night's homework? Anybody? Okay. Well, what we're going to do today, section 6.6, basically, there's nothing new here. It just mixes it all up, throws it all together. So you might deal with a binomial or a trinomial or four terms of factor by grouping or a difference of two squares, take out the greatest common factor, all that stuff we've looked at. So what I want to start with is I want to create a list that I've created over the years. And there is a list in the textbook. I don't know if the online textbook pages correspond to the hard copy, but this is at the beginning of section 6.6. It's on page 477 in the hard copy of the textbook. It says, use a general strategy for factoring polynomials. And then they have this steps for factoring a polynomial. So they have their own list, and I'm going to give you mine. If you don't like mine, you can use theirs or vice versa. All right. So my list starts out with 0.5, and it says standard form, which would be like ax squared plus bx plus c. In other words, descending powers of the variable. Okay. Item number 1 is take out greatest common factor. Item number 2 is difference of two squares. Item number 3 is trinomials, and I've got a Roman numeral 1, Roman numeral 2, and Roman numeral 3. Roman numeral 1 is perfect square trinomials. Roman numeral 2 is trinomials in the form x squared plus bx plus c. So the leading coefficient is a 1. Roman numeral 3 is factor by grouping or by, what is it, trial and check? I can never remember what this book calls it, because there's a guess and check, there's a trial and check. I think it's trial and check. Okay, and then back here 4, factor by grouping. 5, check your, oh, no, that's wrong, sorry. Are you through? And then 6 is check your work. Okay, now Let me go through this because I also want to add this and put a circle here and around here like that. And what am I doing here? Okay, I start with 0.5 because if 0.5 is standard form, then item number 1 is take out the greatest common factor where you're taking out a monomial. Item number 2, difference of 2 squares, binomials. Item number 3, trinomials. Item number 4, factoring by grouping, typically has 4 terms. So I just did that so that the 1 and the 2 and the 3 and the 4 went well with what those items are. Okay, now I've got this red circle and arrow saying standard form moving down to trinomials because standard form is critical with anything 3 terms or beyond that. But remember from yesterday with 2 terms, you're more interested in can you write it as the difference of 2 squares as opposed to standard form. And then on trinomials, Roman numerals 1, 2, and 3, perfect square trinomials, which we looked at yesterday. Trinomials in the form x squared plus bx plus c, that was 6.2. And then Roman numeral 3, factoring by grouping, trial and check, that was 6.3 parts 1 and 2. And this list is important in terms of the order. Again, looking at those Roman numerals 1, 2, and 3, you want to look for them in that order. You don't want to just immediately start with grouping or trial and check. If it's a perfect square trinomial, it's going to be easier to factor than using the grouping. If it has a leading coefficient of a 1, it's going to be easier to factor than using grouping or trial and check. All right, now, I'm going to do a terrible thing, and that is I'm going to move away from this screen so you won't be able to see it if you've been frantically writing it down, but I'm going to refer back to it each time. So I'm going to go ahead and just take some problems and run them through the checklist, okay? But I won't delete this, and anytime you want me to refer back to it, I'll be happy to. This is supposed to be check. All right, so let's take a look at a problem. 32 minus 2 t to the 4th power. All right. That's not in standard form, is it? Because the t to the 4th should be first. However, since it's a binomial, I'm more concerned about, is it the difference of 2 squares than I am, is it in standard form? But even before that, I want to see, is there a greatest common factor? So is there a greatest common factor we could take out of that? Look carefully. Anybody?
16 and 2.
A 2. Good. So then we get 16 minus t to the 4th. Okay. Now, 16 minus t to the 4th is a binomial. It's a difference. Is it a difference of 2 squares? Well, let's see. We could have 4 squared minus t squared squared. So yes, it is. So now my factors become 2 times 4 plus t squared, 4 minus t squared. All right. Any questions so far? Well, let's go back and look at this list here. So difference of 2 squares, factor. Oh, are you through? Are we through yet? No, we're not, because this is also the difference of 2 squares. That would be what? 2 squared minus t squared. So I've got 2 times 4 plus t squared. Now, what about 4 plus t squared? Remember, the sum of 2 squares doesn't factor nicely like the difference of 2 squares. And once any greatest common factor is removed, it doesn't factor further. But now I've got what? 2 plus t, 2 minus t. All right, are you through? I believe we are. What would you do to check your work? You'd multiply it all back together again, okay? So let's see. Now, recall that multiplication is commutative, so we can multiply any 2 factors together in, we can do it in any order we want. Let's see here. Well, this would be 8 plus 2t squared. And this would be 16 plus 8t plus 4t squared plus 2t cubed. And this would be 32 minus 16t plus 16t minus 8t squared plus 8t squared minus 4t cubed plus 4t cubed minus 2t to the fourth. Let's see, those cancel and those cancel and those cancel when I've got 32 minus 2t to the fourth, so it checks. Now, oh, that's not the final answer. This was the final answer, wasn't it? Yeah. I multiplied it together a different way than I pulled it apart. That's more work, but this way I knew that it was right, because sometimes if you factor things and then multiply them back together, sometimes you make the same mistake going both directions, like 6 times 7 is 45 or something like that. So, but again, checking your work would be putting it all back together and seeing that you get what you started with. All right. Any questions about this problem? Let's take a look at another one. 8m squared n cubed minus 24m n to the fourth. Well, this is in standard form in terms of m. It's a binomial though, so I really don't care about standard form yet, but it's okay. Is there a greatest common factor?
Eight.
Okay, anything more?
8m and 3.
Good, 8m n cubed. So what do I have left? M minus 3n. I think that's all that's left. Yep. And m minus 3n, even though it's a binomial with a subtraction sign, there it's not the difference of two squares. Okay. All right. Any questions on that one? 6r squared plus 3rs minus 18s squared. So here we have a trinomial. It's in standard form in terms of the variable r. It has a greatest common factor of a 3. So then I've got 2r squared plus 1rs minus 6s squared. Okay. Now it's a trinomial. It's not a perfect square. It doesn't have a leading coefficient of a 1. So we're either going to use grouping or trial and check. What do you want me to do? You want me to use grouping or the trial and check method?
Grouping.
Grouping. Okay. So A is 2, B is 1, right? Because there's an implied 1 coefficient in the front there. C is -6. The product is -12. The sum is 1. So 4 and -3. There's a product of -12 and a sum of 1. So then this becomes 3 times 2r squared plus 4rs minus 3rs minus 6s squared, which is 3 times, let's see, we're going to use factoring by grouping there. Greatest common factor is 2r with an r plus 2s left over. So here I need an r plus 2s left over and a minus 3s, which works. So now I've got 3 times r plus 2s times 2r minus 3s. And there's the final answer. All right. Questions there? Let's see here. T minus 90 plus t squared. This is a trinomial, so standard form is important, and it's not in standard form yet. So I'll rewrite it, t squared plus t minus 90 There's no greatest common factor. It's not a perfect square because 90 isn't a square and it's got a minus sign in front of it anyway. But it does have a leading coefficient of a 1. So we're looking for a product that's negative 90 and a sum that's positive 1. How about 10 and negative 9? And those numbers go straight in the answer. Remember, when the leading coefficient is a 1, we don't have to use all that grouping stuff. We just put those right into the binomial factors. Let's see here. AB squared minus 4A plus 3B squared minus 12. So here we have 4 terms. And let's see. Well, standard form's kind of fuzzy there, isn't it? Because we've got 2 terms with A and 2 terms with B squared. And let's just deal with it and see what we can do. There's no greatest common factor for all 4 terms. Let's use factoring by grouping and see if we can deal with it just as it is. So the greatest common factor of the first 2 terms would be A, and the leftovers would be B squared minus 1. Well, if that's going to work, then we have to have a B squared minus 1 over here. Oh, it isn't B squared minus 1, is it? It's B squared minus 4. Yeah, I caught my mistake there in time, fortunately. Minus 4, minus 4. I caught it because over here it was like, that wasn't going to work. Let's see here. So then we've got to have a plus 3, which gives me 3b squared minus 12. Okay. So then I've got b squared minus 4 times a plus 3. And the question comes up, are we through? Are we done?
No, you can factor the b squared minus 4.
Right, b squared minus 4 is the difference of 2 squares, b plus 2, b minus 2. Now we're through. So you always want to make sure there isn't something you can factor further. Good job. Let's see here. Let's do this one. 6t to the 4th plus 14t cubed minus 40t squared. So this is a trinomial. It's in standard form. There is a greatest common factor of what? 2t squared. So that gives me 3t squared plus 7t minus 20. The trinomial that remains is not a perfect square. It doesn't have a leading coefficient of a 1. So I'll go ahead and use grouping. So A is 3, B is 7, C is negative 20, the product is negative 60, the sum is 7. Product of negative 60, sum of 7. So I need a negative product, so I need a positive factor and a negative factor. I have a positive sum, so the bigger number has to be positive. How about 60 and negative 1? Well, that would give me a sum of 59. How about 30 and negative 2? That gives me the right product, but a sum of 28. How about 15 and negative 4? That gives me the right product, but a sum of 11. Well, let's see. I can't take 15 and cut it in half anymore, but I could take a 3 out. So if I divide by 3 and multiply by 3, I get negative 7. Oh, I've got the right number, but the wrong sign. So if I come back here and I change this to a negative and that to a positive, would that do it? Negative 5 and a positive 12 has a product of negative 60 and a sum of positive 7. So my 2 numbers are negative 5 and 12. Now, if you can look at it without doing all that stuff and come up with those numbers in your head, then you don't need to do all this stuff I'm doing here. I'm just trying to give you a way to get there if you're feeling like the deer with the headlights, you know, kind of thing. All right. So now I've got 2t squared, 3t squared minus 5t plus 12t minus 20, which is 2t squared. I'm going to factor by grouping. So I get t times 3t minus 5. So over here, 3t minus 5 and a plus 4, and that works. So now I've got 2t squared, 3t minus 5, t plus 4. I've got a couple of binomial factors, but neither one of those is the difference of two squares, so that should be it. Any questions there? Does anybody need to look back? I told you I'd refer back to this. Does anybody need that anymore to write it down or anything? There it is if you need it. Okay, let's see here. How about this one? X squared, y squared, minus 2x squared, minus y squared plus 2. So I've got 4 terms, and again, standard form is kind of ambiguous here. So I'm just going to go ahead and use it grouping as it is and see what happens. The greatest common factor of the first 2 terms would be x squared with a y squared minus 1 left over. So over here, hopefully I can make it work with a y squared minus 1. And, what did I do wrong? I did the same thing last time. This should be a 2, shouldn't it? I was trying to make it into the difference of 2 squares. So now, what would go out in front of that second parentheses? Just a minus 1, right? Okay. Now taking out the greatest common factor, y squared minus 2. There's a difference of 2 squares. I was trying to make that one to work, and it didn't work that way. So now I've got y squared minus 2, and then x plus 1, x minus 1. Questions there? All righty. How about this one? A squared plus 8a plus 3. So this is a trinomial. It's in standard form. It doesn't have a greatest common factor other than a 1. It's not a perfect square. It starts with a square, but it doesn't end with a square. It does have a leading coefficient of a 1, though. So we're going to split it up a and a. The product needs to be 3, and the sum needs to be 8. Well, to get a positive product of 3, we need 2 positive factors or 2 negative factors. But if the numbers are both negative, their sum wouldn't be 8. So the numbers have to be positive. 3 and 1 are the only possibilities, and that does not add up to 8. So what's the conclusion? Prime. Now, be careful. And students will have a tendency sometimes, if something's prime, to just not say anything, but you need to declare that it's prime. In other words, if you just leave it blank, the assumption will be that you didn't do anything with it, okay? So if it's prime, you have to say that it's prime. All righty. How about this one? 12x squared minus 12. This is a binomial. It's in standard form, whether it matters or not, but it has a greatest common factor of a 12. So then we've got 12 times x plus 1 times x minus 1. Let's see here. (25x squared minus 16y squared). This is a binomial. it looks to be the difference of two squares. There's no greatest common factor. So I'm going to have what? 5x squared minus 4y squared. So it's going to be 5x plus 4y times 5x minus 4y. And that's as far as we can go with it. Here's another one. 6x squared minus x minus 16. It's a trinomial in standard form. No greatest common factor. Not a perfect square. Doesn't have a leading coefficient of a 1. So I'll use grouping. A is 6, B is -1, C is -16. The product is -96, and the sum is -1. So I've got two numbers whose product is negative, so it's got to be one positive and one negative, and the sum is negative. But notice this too, and I haven't done this before. The negative number, or the sum, is -1. So that means those two numbers that we're going to add together, one positive and one negative, are only one apart, like 10 and -11, or 6 and -7 kind of thing. So a couple of different ways I could approach this problem. I'm going to approach it the way we normally have it. Then I'm going to go back and look at a different way. Okay, so I know that the larger one has to be negative. So I'd try -96 and 1. Well, that gives me a sum of -95, which is a long ways from where I want to be. But I could cut this in half. And oops, that should apply. Hang on here. Be -96 and +1. If I cut that one in half and double this, I still get -96, but I get a sum of -46. Cut this in half and double that, I still get a product of -96, and I get a sum of -20. Cut that in half and double that, I get a product of -96 and a sum of -4. Cut that in half and double that. Well, now I've gotten a product of -96 and a sum of 10. So I've gone past it, haven't I? Well, let's do this. I'm going to recopy this whole mess up here because I want to have more room. So I took -96 and 1, which gave me a sum of -95. -48 and 2 gave me a sum of -46. -24 and 4 gave me a sum of -20. -12 and 8 gave me a sum of -4. -6 and 16 gave me a sum of 10. What if I switched it around and I made this -16 and 6? That would give me a sum of -10. Well, that would be right back up there, wouldn't it? Okay, so -1 is in here, isn't it? So I need a number, I need a pair of numbers that are right in there. One of them needs to be between -6 and -12, and the other one needs to be between 8 and 16. Well, let's go with the ones between -6 and -12, because there's only -7, -8, -9, -10, -11, okay? So one of those would have to be one of the two numbers we're looking for. Well, -96, -7 doesn't even go into that evenly. -9 doesn't, -10 doesn't, -11 doesn't. So the only one is -8. -8 times what would be -96? Would that be, oh, we've got it right here, don't we? But that would give us a +4. So what's the conclusion here?
Would it be prime?
It would be prime. Okay. Now, I'm going to go back and I'm going to do it a little bit differently. So let's see here. I've got 6x squared minus x minus 16. And let's see. So we said A is 6, B is -1, C is -16. The product is -96, and the sum is -1. All right. Now, back here, I kind of started at the outer edges, the big number, the small number, -96 and 1. But since the sum is -1, remember how I said the two numbers had to be really close together, but one positive and one negative? So instead of starting at the outer edge, I'm going to start in the middle. And how am I going to do that? Well, on my calculator, I'm going to take the square root of 96, okay? And when I do that, I get 9.79795, blah, blah, blah. So I'm going to say this is approximately 10, okay? So that means I need two numbers that are 1 apart that are close to 10, okay? Because this is close to 10, and that's the middle, the square root. So it's like if we took 9.8 times 9.8, we'd get approximately 96, okay? Well, let's see. Does 10 go into 96 evenly? No. 96 divided by 10 doesn't go in evenly. How about 11? How about 12? 12 goes in 8 times, but oh, those are too far apart, aren't they? Because it'd have to be like a 12 and a -8 or a -12 and an 8. We'll go the other direction. How about 9? 9 doesn't go in. 8 goes in, but again, we're arriving at the same idea where it would have to be that. My point is this. In the middle, there aren't two integers that are 1 apart, but yet with opposite signs that give me a product of -96, okay? And if this confused you, don't panic. You can do it the other way, but this is just a way that's maybe a little quicker to determine that, oh, this one is prime, or to come up with the actual numbers, okay? So when would you use this? When this number is big and this number is very small, meaning the numbers are close together. Okay, let's see here. Oh, how about this one? U squared minus 18u plus 81. This is a trinomial in standard form. There's no greatest common factor. It has a leading coefficient of a 1, but it's got a square at the front plus a square at the end. So let's see. Would have to be split up like that. Oh, and it'd have to be negative. Does that work? It sure does. And you could also write it. So you could write it this way or that way. Okay. Let's see here. Oh, how about this one? 16d squared minus 56dz plus 49z squared. This is a trinomial. It's in standard form in terms of d. We have d squared, d to the first power, no d at all. There's no greatest common factor. The leading coefficient is, it's not, wait a minute, it might be a perfect square. 16d squared is a square plus 49z squared, that's a square. So let's see, this would be 4d and 4d and 7z and 7z. The signs would both have to be negative in order to get a negative middle term. Does that give me minus 56dz? There's minus 28 of them, minus 28 of them. Sure enough, it works. Now, you could factor this by grouping and you'd still arrive at the same answer, but it'd be a lot more work. So looking for perfect square trinomials is a good thing to do. It doesn't take long. And if it's right, it's going to save you a lot of other work. Okay. Let's see here. How about this one? 16x squared minus 40x cubed plus 25x to the fourth. This is a trinomial, but it's not in standard form. So let's put it in standard form. Okay. It has a greatest common factor. So let's take out the greatest common factor. What's left might be a perfect square. Starts with a square, ends with a square, and there's a plus sign there in front of the last square. So let's see here, 5x, 4, 4. Again, it would have to be minus. Does that give me minus 40x in the middle? Sure does. So x squared, 5x minus 4, the quantity squared. So you could do it this way or that last way. Okay, let's see here. How about this one? We've got x times the quantity x minus y times the quantity y minus x. The things in parentheses don't match, do they? Could I somehow manipulate this so that the parentheses had x minus y? Let's see. I'm going to do this. I'm going to distribute this. Oops, that's wrong. This would be what? Plus xy, right? Okay. How about if I rearrange this and wrote plus xy minus y squared? Okay. Now, could I get it to look like that? What would I have to take out? Plus y. So basically what I ended up doing was moving things around to where I got things to match. So now I've got xy coming out of both, x plus y. Okay. Oh, those factors are conjugate pairs, aren't they? Let's do this problem a different way. Let's take this whole mess and let's multiply it all out. We get x squared minus xy minus y squared plus xy. Oh, these would cancel. Oh, look at that. Maybe that was easier to see than what I did. Of course, I didn't know ahead of time, but there you go. All righty, how about this one? 25b squared plus 14b plus 49 over 25. You've got a fraction. That doesn't look fun at all. Well, it's a trinomial and it's in standard form. There's no greatest common factor. Oh, 25b squared is a square. Isn't 49 a square and 25 a square? So 49 over 25 would be a square, and there's a plus sign in front. So this is going to be 5b 7/5. You see where I'm getting the 7/5? The square root of 49 is 7. The square root of 25 is 5. Would the operation be addition or subtraction in the middle there? Be addition. Now, that gives me 25b squared up front and 49 25ths at the end, but does it give me 14b in the middle? Let's see. What's 7/5 times 5b? Wouldn't that be 7b? And then the other one would be 7b, and you add them together, you get 14b. So that's true, or you could write it like that. Okay. And let's see here. How about 1/4 minus u squared over 81? Well, this is a binomial. It's a difference. Is it the difference of two squares? Let's see. Isn't 1/2 the quantity squared, 1 squared over 2 squared, or 1/4? And over here I'd have u over 9, u squared over 81. So my factors would be 1/2 plus u over 9 times 1/2 minus u over 9. Fractions are your friend. Just keep telling yourself that. And here's one more fun one. Fun for whom, you say? All right. X to the 4th minus 13x squared plus 36. This is a trinomial. It's in standard form. Let's see. There's no greatest common factor. It's got a leading coefficient of a 1. Oh, it could be a perfect square because it's got a square at the front plus a square at the end. So if that were the case, it'd be x squared, 6, 6, minus, minus. Oh, that doesn't work though, because that doesn't give us minus 13x squared. It gives us minus 12x squared. So it's not a perfect square, okay? So I tried, and it didn't work out to be a perfect square trinomial, but that doesn't mean I'm going to give up. It still has a leading coefficient of a 1. So now the product is 36 and the sum is negative 13. Oh, how about negative 9 and negative 4? That would give us negative 13x squared in the middle. But now look, x squared minus 9, that's the difference of two squares, x plus 3, x minus 3. And x squared minus 4, that's the difference of two squares, x plus 2, x minus 2. This is like a math teacher's dream come true. It's got a trinomial that you factor, and then you take the result and factor the difference of two squares. It's got a little bit of everything there. Let's throw in a greatest common factor and call it good. Whatever. All right. Anyway, there you go. All righty. I'm going to go ahead and stop the recording.